All right, today we're going to talk about solving literal equations. Now, first off, what is a literal equation? Okay, at the top of the screen, you should see 4 different examples of types of literal equations. So by looking at those, what can you assume literal equations are? Okay, so now I'm going to give you the definition. Literal equation is an equation which consists primarily of letters. Okay, what we typically say letters are variables. So formulas are a good example of literal equations. Now, in solving literal equations, we can rearrange literal equations to isolate a specific variable. We might do this to, have it already solved if we're dealing with a formula and we need something solved. Then we oftentimes will solve these for a specific variable. So that way it's already solved and all we have to do is plug in. So if we know certain values for a variable, rearranging the equation can make it quicker to solve for the missing variable. All right, rearranging a literal equation. We still use inverse operations and work backwards. Okay, just like when we would solve a regular equation. To undo each operation that happens, so we're just working backwards just like we would with solving a regular. All right, so here's our first 2 sets of examples. Now, in this one it says solve for x. So I've got a regular equation and I'm going to solve that first. All right, so we're solving for x. Okay, so I'm going to highlight that just so I know which variable I want. Especially this is helpful when we get to solving the literal. All right, drawing my line. Now looking at this, I've got 2x minus 4 is equal to 8. So the first thing I'm going to do is undo that constant and add 4 to both sides. And it leaves me with 2x is equal to 8 plus 4 is 12. All right, from here, I still have something with the x. So I'm going to divide by 2 because the 2 is multiplying to x. Okay, 2 divided by 2 becomes 1. So I'm left with my x equal to 12 divided by 2, which is 6. Okay, so now I want you to pay attention to the steps I do when I solve this one over here. All right, so we're still isolating x. We're still solving for x. So I'm going to work the same process, but this time I have to add 4y because the 4y is subtracting from the x. Now looking at this, I need to move my line a little bit so I have space. Okay. All right, 8 plus 4y. Well, they're not like terms, so I can't combine them. So I'm going to end up with 2x is equal to 8 plus 4y. Okay? I'm going to write that just a smidge better. Hang on. It's a little hard to read there. Okay, so now I still have this 2 times x. Well, how do we undo something that's multiplying? We divide it. And I get x is equal to 8 plus 4y. Oof. divided by 2. Okay? So, same steps we did on the A, right? I added 4 to both sides. Well, here I added 4y. Okay, and then on both of them, divided by 2. So, think about what the differences are. Okay? All right, let's look at the next set. Okay, I've got 3 minus y is equal to 5. So first thing I'm going to do, okay, I'm isolating y on this one. So it says, my instructions say solve for y. So I'm isolating y. So again, first thing I need to do is move that constant. Remember, the constant is the number by itself. So I'm subtracting 3 from both sides. That leaves me with a negative y equal to 5 minus 3 is 2. All right. Now I'm not quite done yet because I still have that negative in front of the y, don't I? And remember, there's that invisible 1 that's there. So I'm going to divide both sides by a negative 1. And we get y is equal to negative 2. Okay? So let's look at solving the second equation. All right, again, I've got a very similar equation, except for this time I've got 3x minus y. Well, the steps are still going to be the same. Subtract 3x, and I get negative y is equal to, well, again, in this one, 5 minus 3x, those are not like terms, so I have to leave it as 5 minus 3x. Okay, I still have that negative in front of the y, so I'm going to divide by a negative 1. And I get y is equal to 5 minus 3x divided by a negative 1. All right, we're going to look at one more set. All right, so we're going to continue solving. So now looking at this, okay, this first equation over here, I'm going to subtract 4 on both sides of my equal sign. Okay. Which gives me 3x equal to 13 minus 4 is 9. Divide both sides by 3. And I get x is equal to 3. Okay, so let's go ahead and look at the second one, which is ax plus b equals c. Now notice in this one I don't have any numbers, but the inverse operations still work with our variables. So I'm going to minus b on both sides in this case, since it's what's adding to x. And I get ax, is that a? Okay. Ax is equal to c minus b. Okay, so c and b are not like terms, so I can't simplify them. Next thing I'm going to do is I'm going to divide both sides by a, because a is multiplying to the x. So I get x is equal to c minus b divided by a. And there's my answer. All right, so just kind of some thoughts to think about. What were the similarities between the equations? And what were the differences? And we will discuss this further in the next lesson.